Hello guys. So today we're going to be dealing with finding the orthonormal projection vector onto a vector capital L. And the steps we will take to find that is one, find the unit vector lowercase l in the direction of capital L. Number two, find the projection of the vector v onto the vector capital L by doing the dot product between the vector v and the unit vector lowercase l. Then three, find the vector v parallel to capital L or lowercase l, which is basically the projection of v onto capital L, by multiplying the scalar dot product mentioned before in step 2 times the unit vector lowercase l. This is to add direction to the actual projection vector, projection of vector v onto the vector l, which is the vector v parallel. And then number 4, it will be use the vector addition property to solve for the orthonormal vector b perpendicular, given the fact that the vector addition properties where the vector v itself is the addition of the components, one the parallel one to the vector capital L, and then the other one perpendicular one to the capital vector L. Yes, and then we're gonna move on to document page 2. Okay, this is the work done basically. Here in this work, as you can see, we start with the vector capital L, -1, 2, 2. I use the bracket notation, the open bracket notation. We start also with the v vector 7, 9, 6. We're dealing in a three-dimensional space, and I calculate the magnitude of the vector capital L, which gives me 3, right? That will be the magnitude. If I multiply by the reciprocal of that magnitude, I make capital L into a unit vector called lowercase l vector. Then I proceed to find the projection of the vector v onto capital L, which is the same thing as multiplying the vector, doing the dot product between the vector v and the lowercase l vector. The reason why I'm doing this is because I'm only trying to find the projection of v onto the direction of capital L. I'm not really actually trying to find what the dot product is between capital L and v. Just the projection, like the shadow of it on the vector capital L. So we do the procedure of doing the dot product, and that leads us to a simplification of 23 over 3. By the way, another notation for the projection of v onto L is a magnitude of the vector parallel to capital L, which gives you 23 over 3. And then what we're actually looking for right now is the actual vector b parallel. And to get this, we actually multiply the scalar magnitude of the vector, which is the projection, times the direction of the vector L, but as a unit vector. So we already calculated the unit vector of capital L, which is lowercase l, and that just gives us 23 over 3 times the vector lowercase l. Hopefully the pink phrases or statements give you a good notion of what these labels represent. And then of course we have a little diagram here on the left side, and then we can see that the vector addition property, if we solve for the b perpendicular vector, we get v vector minus v parallel b parallel vector. So subtraction of vectors to find orthonormal vector projection, right? And we're actually trying to find the vector, not the magnitude. So we just do these operations and we end up with b perpendicular orthonormal vector, brackets, open brackets, 86 over 9, comma 17 over 9, comma 17 over 9.